That's one of my mantras I keep. Infinity times anything equals infinity. Good evening, everybody. Happy New Year. Welcome to 2024. It's office hours time again. Hope you've had if you've had a rest or some time off, hope you're well rested and ready to go. I had a little bit of rest over the time off. We shut down Ask Tom for a couple of weeks and made some changes to it. And obviously you've seen the new office hours and stuff as well, but we moved Ask Tom to a brand new server and all sorts of goodies. So other than that, it's been a pretty quiet time. And I should say, hopefully you can hear me. Hopefully you can see me. Sing out on the chat line as per normal if you can't. But other than that, yeah, we've got a lot of things to get through to start off. And some conferences coming up, all the normal stuff on office hours. So as always, throw your questions or in the Q&A or the chat. I don't care either way. Oh, hold on. I always forget. I need to be able to turn the chat on for everyone, don't I? It's always turned off for everyone. So everyone can chat now. So that's good. So we'll get that sorted as well. Okay, let me share my screen and we'll get straight into it. Can someone just throw something on the chat to everyone just to make sure that's working, but I'm pretty sure it is. Hopefully you can see my screen. Hopefully you can still see me. I can no longer see me, which is not meant to be right, but let's try that. Okay, hopefully we're good to go. As always, getting in touch is easy. Standard opening slide. You can scan the QR code. You can go to linktree/Connor, or easiest, head over to Twitter on Connor MCD. My DMs are always open. Always happy to talk tech if you have questions or anything that springs to mind after the session. As I always say, no need to adjust what's going on here. The slides always have their content sort of either tucked down to the left or down toward the bottom. This is so when we turn this into a video, I can superimpose things like demos on myself in the right spot, and we don't get that annoyance where the webcam or some other part of the demo is masked by the camera. So hopefully it all works out well. As always, I like to start off with some bits and pieces, what's been happening, what's coming up soon. Mainly this is what's coming up. As you may have known, there's some new office hours tech going out there. It's called the Tech Session Planner, the Tech Session Catalog. It's still embedded within Ask Tom, so nothing should really change, and any historical office hours you should also be able to get to. If you ever have any dramas with it, please ping me on Twitter, let me know. I've already had one query tonight, which I'll research. But yeah, we're still working through, finalizing the solution. I'm pretty happy with it. It seems a bit more professional looking. The UI is a bit better, but obviously we're gonna find a few little bugs here and there, which we will fix as we go. Big news today. I'm thrilled that my office hours coincided with this. That was purely a coincidence. SQL developer for VS Code. Now, unless you've been living under a rock, you're probably familiar that VS Code is pretty much the go-to IDE for just about every developer nowadays. Now, perhaps the exception would be those people who are dedicated and solely database developers, who I'm sure are either using things like SQL CL, SQL Developer, the Java version, or the product that looks like a frog. We don't say Toad around here. But either way, they're the common tools. But everyone else pretty much uses VS Code pretty much across the board, and it's incredibly powerful. Even just as a text editor, it's awesome. But its ability to have plugins and extensions has made it absolutely fantastic, which leads us to SQL Developer for VS Code. I literally, I played internally with the beta for a few months, but today was my first chance to really, just grab the production version. And don't get me wrong, same thing, brand new code. We've got that for 2024. There'll be a few little edge cases and stuff where things might not work as you'd expect. And it'll slowly over time pick up all the stuff that was in SQL CL and SQL Developer. So we're basically similar to our 23C release. We've put it out with the set of important production quality features, and the rest will get put in over time. But one thing you will notice is it is blazingly fast. You fire up VS Code, which literally starts like that, and then you basically click and you are off and running. So people's main criticism sometimes of the SQL Dev in Java was the startup time and perhaps the responsiveness of it. This will blow your mind. So get out there, literally you just, VS Code is just, it's not an install. You simply download a zip, unzip it, and you'll go. Simply search in the extensions area for SQL Developer for VS Code, and you are good to go. It is literally that easy. So pretty cool. And if you have any questions or thoughts about it, ping us on Twitter, let us know. What's coming up in the next couple of months? The Swiss Database Circle Conference is coming up very soon, just in a couple of weeks, I think, 30th of January, sometime like that. So if you're in Europe, try to get along to that. Shortly after that, we've got the Rocky Mountain Oracle User Group, probably one of the longer running user groups, been around for maybe 20, 30 years even, a long time. I've been fortunate enough to speak there a couple of times. I won't be speaking this year, but I've got some other commitments to go to. But yeah, get along if you're in the north of the US. And once again, it's Cloud World time, not Cloud World Las Vegas, which comes at the end of the year, but we do this thing called the Cloud World World Tour, which really is that chance for, a lot of people are going, yeah, great. I don't really want to fly from Africa or Europe or Asia to Las Vegas. And, that's a long flight, expensive flight. So we're trying to bring, call it a highlights package, bring the highlights around the world. So what's coming up? We've got Mumbai, which is coming up. In fact, Dubai, I think might have just started or was about to start. Then we got London, we got Mumbai, we got some others as well. But I'll be at Mumbai. So if you're in Mumbai for Cloud World, please come say hello. I'd love to say hi. And as I said, unlike Cloud World in Las Vegas, because it's a massive scale event that you have to pay for, these ones are all free. You simply head over to, just search for, basically oracle.com Cloud World. Basically click the city that's closest to you, register, and you are good to go. What we've got in each one, typically it's across, once again, the entire Oracle stack, but in each of the ones we've got about 10 to 20 database and developer style sessions. Generally sort of the high value ones that we came out of Cloud World Vegas, plus also the fact that the world has changed in the last 6 months. Literally AI has taken over the world. So there's some elements on our new AI offerings and vector database, etc. So lots of cool stuff there. Once again, if you're in Mumbai, please come say hello. Speaking of which, given that there's going to be plenty of people in India at Cloud World Mumbai, I've joined up, and a number of other Oracle people have joined up with the All India Oracle User Group run by Sai, to run some whole day events on the weekends either side. So if you can't get to Mumbai, but you're in India, you can get along to Delhi, Pune, I've forgotten already. Delhi, Pune, Mumbai, and Bangalore. I think I got that right. I might have got one of them wrong. I might have put the wrong dots on. But anyway, yes, I have got the wrong dots. Yes, it's Delhi, because Mumbai is Cloud World. It's Delhi, Pune, Hyderabad, Bangalore. There we go, or Bengaluru. So please, in those 4 cities, check the AIOUG website, special events, and we've got a number of senior VPs, executive vice presidents, and me. I'm like the budget version to talk at these events. Plus, they're also multi-cloud, so there's people there from the other cloud vendors as well. So lots of cool stuff in those events. Now, it's funny how funny story for you before you tuck into the content. People say, oh, you get to travel, you must have such a glamorous life. I'll let you know, I was on the phone today for 2 hours trying to attach the ability to carry any kind of luggage on one of my flights due to a misbooking from one of our internal booking sites. And so my glamorous life was 2 hours on hold, and you can see this position here. This is not me making it up. This is a real screen recording of me in the chat line. Obviously, the people that hopefully wrote this chat thing maybe weren't familiar with the concept of a queue. Maybe they should be using Oracle queues. But anyway, so just before you think, oh yes, Connor gets to travel everywhere, rest assured, I have all the hassles of travel like everyone else has in the world. But all these things, as always, I'm saying, support your local user groups. I know I sound like a broken record, but historically, before I joined Oracle, I was active in user groups. So please, wherever you are in the world, find your local meetups, and get those user groups back on track. What are we talking about tonight? Parsing Excel files. This is the worst code. I can't remember where I put this in the order, but it's funny how someone sent me a question saying, what's the worst piece of code you've ever seen? And I thought I had to think long and hard about that. Thankfully, or maybe this is a bias, it wasn't one of my own, but I thought I'd present it tonight. Some hints and tips in tips for avoiding duplicates in terms of performance. The append values hint, which can be used in PL SQL. Hybrid partitions, something which I think is underrated, and perhaps because when they first came out way back, I think maybe Oracle 11, maybe Oracle 12, somewhere around there, they were sort of a fairly sort of naive implementation, but now they're very, very cool. So we'll talk about that. The access and filter operations of the execution plan, and automatic transaction rollback, which is a 23C feature I've demoed that before, but someone's asked me some permutations on that. So 7 things to get through. We're 10 minutes in. Let's get stuck into it. As always, that piece of chat line. Microsoft Teams. It's okay, Microsoft. Sorry, I'm lost on what you mean by Microsoft Teams. Oh, worst code. That's a fair call. Yep. That's why I use Zoom. But yes, I must admit, I shouldn't be dumping on Microsoft, given that I use Microsoft Windows machines and I do like them. But yes, I must admit, every time a major Windows update comes in and they sneak Teams back on, I generally go in and uninstall Teams. But that's just my personal thing. Let's get into it. Parsing Excel spreadsheets. This is the question that came in. We are using the Apex data parser to parse Excel files, but it's not fast enough for larger options. Let me start again, this time getting the sentences sorted out. We are using Apex data parser to parse Excel files, but it's not fast enough for large files. What are our options? And before I jump into the demo, just to let you know that if you've not seen Apex data parser, pretty sure it's written by Carsten and Carsten's team in the Apex group. It's a magnificent piece of code because literally you can throw just about anything at it. JSON, Excel files, XLS files, CSV files, etc. And it will just go through and sort of sort out the mess and turn it into a relational structure for you. So very, very cool and avoids a lot of the hassles. I mean, I've lost count of the number of times I've seen people writing these things in UTL file, etc. This is a wonderful one-stop shop to parse just about anything. Obviously, with flexibility comes a bit of a price, which is it's basically going to have some performance challenges because it has to be all things to all people. Let's have a look at how we can improve it. So first demo for the night. So let's do an example here. So I'm going to create a table called T, which has got a blob, and I'm going to insert into that a large Excel spreadsheet. Now we can look at the size of that. It's about 5 megabytes in size. Now that might not seem big, but if you're unfamiliar, XLSX files, and the same with Word, like docx files and PPTX files for PowerPoint, the X basically stands for compressed. They use an open XML format internally, but then before they save it, they actually zip it. You can actually open a XLS file with things like WinZip or 7Z, those kind of unzipping tools. It's a compressed file. So even though it's 5 meg, that's 5 meg compressed. Typically, it's going to balloon out to much, much more than that, especially if you have a lot of repeated data in there. One thing I should notice the insert there. I mentioned this in a previous office hours session. You can just do to blob on a B file name and it loads in a blob into your table. Don't have to worry about dbms lob load from file and all that kind of stuff. But it's 5 megs in size. Now, I'm going to set this running. I said, note, set this running. This is how easy Apex data parser is. You can see there it simply says I want to parse the blob. I give it a file name so the Apex data parser knows that I'm dealing with an XLSX file. And all it does is it's unzipping that file, probing all the cells in the XML and turning it into relational data, and it returns it as effectively a pipeline structure. So you can just put a table around it and out you get back a nested table. Super, super cool. Now, as you can see, this is the slight performance overhead. My machine's obviously at the moment running Zoom as well and recording the session, but it chunked away for about 32 seconds. Now, one thing I should mention here is there is a separate optimization for Apex data parser, no matter what you're dealing with, which is if a blob you're dealing with is larger than 50 megabytes, often people see things that run quite like extra slow, so to speak. The reason for that is we don't know how big a blob you're going to pass in. So ideally, when you're dealing with a blob, what you want to do is cache that blob in memory and then work with just the memory. But we can't do that automatically every single time because you might load a 5 gigabyte blob or a 100 gigabyte blob or an exabyte, some huge blob. We can't just go, let's just jam that into RAM. We could destroy the server. So Apex data parser by default says if it's less than 50 meg, I'll cache it. If it's more than 50 meg, I won't cache it. If you know that you've got more than 50 meg of plenty of RAM and that's not an issue for you, here's a workaround. What you do is you take your blob, convert it to being a cached one, and then use the cached one in your actual query. So you manually say, I'm going to force it into cache, into memory, and then deal with the cache. So if your blobs are larger than 50 megabytes, that's a good workaround to make things faster. This one was only 5 megabytes, so it was cached anyway, but it still took 32 seconds to extract those 50,000 rows. And the question is, can we do better? So one thing I would look at doing is, as I said, Apex Data Parser has to be all things to all people. It has to accommodate all sorts of different sort of file formats, etc. And ultimately, it's a pure SQL program, which is interpreted. There are other facilities that might do a better job. And here's an example. Here's a little batch file I've written, which uses Python. There's a nice little Python library called XL to CSV. So this will simply run Python to take my XLS file and pump it out as CSV. Now, CSV still doesn't turn it into a relational table, but if I have CSV, then I can obviously take use of an external table. So here's what my little Python program is. It simply pulls in some libraries and simply says, read my file name in, load the workbook, and simply write all the contents out to a CSV file. Once that's done, here I can do an external table to simply pull in the CSV. So here's my Excel file. Here's all the columns in there because this Excel file is just multiple copies of DBA objects. And here's the sort of the magic of external tables. It simply says, I'm going to use a preprocessor. So in comes my file, but the first thing I'll do is I'll take that file and I'll pass it into this program, which is a batch file on Windows, which ultimately calls Python, which calls that Python library, which takes my Excel spreadsheet, converts it to CSV, which means the rest of it is just basically using CSV, comma separated file, etc. List out what the date formats will be, and off we go. So let's give that a run. Remember, the Apex Data Parser took about 32 seconds for the 5 megabyte file. So now we're using database, calling Python, converting to CSV, using external tables to read the CSV to convert it to a relational table. We'll see how we go. So 18 seconds, almost twice as fast. And the moment you can get your head around the fact that we can now use external tables to drag in other tools that might be better suited to the job, well, we just keep Googling around, I suppose. So here's the exact same metaphor, but I went hunting around and I found a slightly better Python library. This one's called xlsx to csv.py. Other than that, it's the same. It's just a different Python library. So I create a second external table, and all it's doing is calling this new version, CSV number 2 of batch file, which calls the different Python library. Create the table. Other than that, it's pretty much the same. I'm passing in my Excel spreadsheet, and off we go. Anyone that's familiar with external tables will know that you don't actually have to create an external table anymore. You can actually write that entire piece of DDL just in a select statement nowadays. So you don't even have to create an object anymore, an external table object. And this one's down to 10 seconds. So I've got myself a 300% performance improvement, or as we often say at Oracle, a 3x performance improvement just by switching out to perhaps a different tool. Other than that, it's no different, in the sense that it's still a relational object. So I can still put where clauses on it. As you saw, it's account start. I don't have to just get the data back. I can do all the normal power of the SQL engine, but I'm still parsing an XLX file very, very efficiently into a relational structure. That's pretty cool. Let's minimize that and head back to the slide. So in a nutshell, what I'm really saying is when you're coming to parsing data, look at using the right tool for the right job. I'll give you a similar example on social media. You may have seen on Twitter, someone was posting this really cool thing called the billion row CSV challenge, which was you've got a CSV file and how fast can you sort of summarize the data that's a billion rows using a Java program. And it was an invitation for people to come up with various Java libraries, Java algorithms, etc., to see how fast they could parse it. It's funny, I think the fastest I saw using a 16 CPU sort of Amazon sort of instance was about 7 seconds. I did an interesting thing where I loaded it into a table, put it into in-memory, and I could do the whole thing in just over 2 seconds. So as I said, when it comes to processing data, databases are probably the best idea, but it all comes back to right tool, right job, and that's really what you want to be seeking when you have to process data. So hopefully that makes sense. Bit of Q&A. Here we go. Victor's nominated another possible tool, the Oracle Database plugin for IntelliJ. Same thing, right? Basically, anything where effectively the database can reach out to use tools that are specifically suited for certain tasks, I think you're going to get a benefit from them. And yeah, my footnote here is external tables are awesome nowadays. I've almost, I really can't think anymore of a use for using UTL file to actually read a CSV file in, or even any kind of flat file, because an external table, especially when you're throwing the preprocessor, which lets you do some work beforehand to the file if needed, pretty much obviates the need for that. So yeah, I think UTL file is almost obsolete for that particular purpose. Maybe also even SQL loader. Q&A's come in. That's live, done. Okie dokie. Let's move on. Append versus append values. Here's the question that came in. I know that we can do a direct load with the append hint, but I also saw the append values hint. What is the benefit of that? And append values is really designed for PL SQL, and let's jump straight into a demo to have a look at how it works. So I'm going to create a table called T. It's the same structure as DBA objects, but where 1 equals 0 means it's starting off as empty. Then I'm going to create another table called T1, and it's 20 copies of DBA objects. So I think this database has about 80, 90,000. So what have we got? Maybe 800,000 rows, somewhere in that vicinity, maybe 1 million rows, give or take. Just lots of rows. Oh, and look, what do we got? 1.7 million rows. There we go. So let's now, using PL SQL, using the bulk binding facility, see how long it would take to copy those 1.7 million rows into that empty table called T I first created. And we see it took about 5 seconds. Real easy way of doing benchmarking is just have a couple of timestamp columns. So effectively start the timestamp at the end, timestamp at the finish, and simply do one minus the other, and you get an interval as a data type, which tells you the number of seconds. So this is just using bulk collect and bulk bind to basically, rather than doing 1.7 million insert statements, just do a single insert statement to see how fast we can smash rows in. Now, I want to stress, we wouldn't normally do it like this because 1.7 million rows is a big giant heap of PGA. This is just basically looking at the edge case of how fast can we do an insert in PL SQL compared to what happens now when we put the append values hint in. Because what append values does is mimics the append hint, which is a direct load operation, building blocks rather than rows and slamming those blocks in order to gain some efficiencies. So 5 seconds for just a standard insert. And let's now repeat that exact same demo, empty table, and now basically do append values. So this is now doing the more direct load insert, which we normally see significant performance benefits on. So it's up and running. Remember the first one was 5 seconds. And here we got 4.7 seconds. Wow. We gained 0.3 of a second. So what's that? Maybe, I don't know, what's that? Maybe 5%? 5% benefit. And what's the price? Well, when you do a direct load insert, whether it's append values or append, you've locked the entire table. So there's that issue, which generally kills concurrency. Have I really gained anything? I'm not entirely convinced, but maybe, this is just a special case. So let's proceed onwards. And we're going to work in some various permutations here. So once again, drop table called T, which is our target, make it empty, and let's try something different. What about a stock standard insert select? That takes 3 seconds. So already you can see that concept, which has always been true, is if you can do something in SQL as opposed to doing it in PL SQL, you're generally going to get some benefit. So in reality, doing it along those lines is going to be better. Let me truncate that table now and use insert append and see what we get there. And same thing, we get on an empty table, we get around about just this small benefit. And we've had that price of locking the entire table. So maybe it's not really a problem with the append values hint. Maybe this is a special case where if I'm just doing a simple insert into an empty table, which has no rows in it and no indexes, etc., then maybe insert and insert append actually aren't that much different. Let's keep exploring. What about if the table's no logging? Because anyone that's done data warehouses knows that one of our recommendations is if you've got some big tables to load, then we want no indexes, no logging, and then your direct load insert. Maybe this is where append values is going to sort of come into its own. So I'll trunk up my table called T, it's no logging. Let's do an insert append. And we can see that this is probably a more realistic example. If I had a standard insert, which had with logging, because inserts are logged always, I get 3 seconds. If I had no logging insert append, I get 1.9 seconds. So that's what, 40% faster. So there is genuine benefit in using insert append in these particular scenarios. Obviously, that has implications in terms of data guard and standby, etc. But once again, if we're just looking for flat out loading performance, there is a genuine benefit to insert append. So maybe this is what we have to do with insert append values as well. So this time I'll insert make table logging and just do back to our normal sort of insert thing. The table is now logging, truncate it. Once again, we do this comparison with our normal insert, which is going to be about 5 seconds again, 4.3 this time, right? Let's make it no logging and use append values, because in theory, it should replicate the benefits of append. So this time we're using a no logging table, append values, and see what happens. And no, we don't really see much benefit of append values there either, which is odd because the SQL equivalent did see significant benefit, whereas this one, we didn't really see much benefit. So, well, let's try something different again, okay? Maybe it's not about loading into empty tables, because another benefit of direct load is it defers things like index maintenance, and it always inserts after the high water mark. So if you have a table which has, or maybe I should keep this going. Yep. Let me create this table as empty and then put some indexes on. Yeah, I should have done this right. There we go. So one of the benefits of direct load insert is it inserts at the end of the high water mark, and also it defers index maintenance. It basically collects batches of rows through index maintenance in batches. So maybe those previous examples with append values where the table had no indexes are selling append values short. Maybe once we get indexes involved, we're going to start seeing some benefits over a normal insert. So once again, this time I'm just going to look at 800,000 rows because I've now got 3 indexes worth of maintenance to do. So I use the normal insert and we'll see how long it takes. This might take a little longer because we've got 3 indexes to maintain while we're doing the insert as well. Come on, little PC, it's doing its best. That one took 15 seconds. Now, when we use append values, we'll have deferred index maintenance. So let's give append values a go for the exact same thing and see if we get better than 15 seconds. It's running, and 10 seconds. So here's perhaps one example, right, where maybe we're going to start seeing some benefits here. Okay, what's this, about 30% faster because we had that deferred index maintenance. One last example I will throw there is, once again, a copy of T1, so another 1.7 million rows. We'll throw some indexes on, and what we'll do this time is we will, delete every second row. Now, the reason I threw this example in there, another thing that append shouldn't have to worry about is finding blocks that are on the free list, because it simply adds rows to the end. It doesn't care that there are blocks inside the database that are candidates for filling up again because they got some free space in them. So this is another example where maybe append values should give us some benefit. So here's our stock standard insert now. So once again, 3 indexes, and we're filling in gaps of free space as well. Chug. Okay, 9 seconds, and let's throw in our append values. See how we go. And 12 seconds. So after all that, I think the easiest way of describing that is this. Almost exclusively, in almost all cases, I very rarely see anything that really justifies the use of append values, to be honest. I know that's a strange result, and you probably will think, oh, he's going to show us these wonderful results here. I've very rarely seen any benefit. And these all should be almost like best case scenarios, because I'm using massive amounts of PL SQL arrays. I'm not grabbing 100 rows and going again, 100 rows going again. I'm getting huge, big, hundreds of thousands of rows and doing them all in one big hit. So the append values benefit should be significant. So I suppose what I'm saying is, if you have any examples, please ping me on Twitter, let me know. But so far, I'm unconvinced. The cost of having to lock the table for what I've yet to see as any real tangible performance benefits, I'm not convinced. So my rule of thumb, I won't say this is a cast iron recommendation because we never say that here at Oracle, but my idea is at the moment is I would not use append values. Simply that. I would be using SQL wherever possible. If I am doing some bulk operation that requires PL SQL, I'm going to use all the normal practices: bulk collect to get the data in, bulk bind to get the data out. But other than that, I really can't see much benefit from append values, and I just don't think it outweighs the cost of locking the entire object. So that's my thoughts. Happily for someone to send me a test case that proves me wrong. I'll ask around internally, but yeah, I'm not convinced on append values at this point in time. Okay. Oh, question. You're just saying, could it be that with append values, each single row goes in a new block? Yes, if you were basically doing insert append values and just a single, like 1 or 2 rows, then yeah, each one would go into a new block above the high water mark. But don't forget, you would have to commit every single one of those as well, because it's the same direct mode operation. You would do insert append values, have to commit. Next insert append values, have to commit. So yeah, I'm not entirely convinced still, but yeah, good point. Hybrid partitions. These are pretty cool. Here's the question that came in. We are looking at hybrid partitions for old data as a means of reducing our table size footprint. Are there any restrictions we need to know about? And before I say what the restrictions are, I think this is a really cool idea, because for decades, we've always said there's an opportunity to reduce the working size of your database by putting old data in things like read-only table spaces. And so you do things like you make them read-only, therefore you don't have to back them up as frequently. You don't have to worry about checkpointing and stuff like that. They're out there, but they're still really part of the database. They still occupy size. Whereas putting data in outside the database in, say, actually flat files or things like object storage, if you're on cloud, because that's super, super cheap, then I think you are genuinely now having a smaller database with sort of pointers out to the outside world. So I think there's a huge opportunity for read-only old data to be simply dragged out of your database, yet still be accessible as if it was there for people for that ad hoc sort of query. So I think there's a big opportunity here which we've yet to tap into. But the question is, are there restrictions? Well, yeah. If you head to the docs, there's a whole stack of them. Now, I should say all these ones seem relatively straightforward. Obviously, you can't, read-write the data, and you can't have sort of various bits and pieces that would make sense if you're looking at a flat file. You can't have indexes on them, etc., because obviously the data is out there. There's no structure to it. It's not row ID, etc. So all the normal things that you would expect make sense here. They are genuine restrictions. You think that makes sense. However, even when you read all of those, you think, yep, I'm good to go. I'm pretty sure I know what I'm doing here. There are a couple of gotchas that are not really covered explicitly in the documentations. I wanted to put them in here. I wouldn't call them restrictions, but things that could catch you out. So I thought I'd talk about them here because they're very useful to know if you're heading down this path, which I've just sort of endorsed saying it's a really good idea. So let's look at some examples. So I'm going to create a table here called sales, and it's got 3 years worth of data: 2017, 2018, 2019, typical range partition. And I'm going to insert huge amounts of data. Well, what have I got? 6 rows, but that's enough. At least we've got some rows in each of the partitions. That's all we need for this demo. We're not doing any massive archiving here. One of the things that is sort of good to get your head around is a hybrid partition table. You can think of it as actually being an external table with some non-external components. So what we actually do is when we have a hybrid partition table, the first thing we do is we tell the database this table is going to have the following attributes when it comes to its external partitions. So they're going to be data pump files by default. In my case, this is where you're going to find them in the temp directory, and I'm not going to bother with log files and stuff like that. So now I can do things like this. I'm going to add a brand new partition called sales 2020 because we had 17, 18, and 19. Put a range in there, but the location is actually a dump file. It may be a data pump sort of dumper file. let me clarify that very carefully. It may be a data pump format style of file. You can't actually take a data pump dump file and use it as an external partition, because a data pump file has all sorts of metadata in it as well. This is actually a data pump format file, which you used using create table as select. But as you can see, I can create a brand new partition, which is a external file rather than a relational object. So let's look at our first gotcha. The first gotcha, which you need to be aware of, is just like a normal partition table where you can't add a partition back into the history, you can't add a partition of a hybrid thing back in the history either. Even though you think that should be allowed, because I'm actually sort of, I'm not touching the existing structure, because you're nominating a values less than, then that would implicitly be the equivalent of doing a split partition on the earliest partition. And of course, it makes no sense to split a partition which is relational into half relational, half hybrid. You would have to do that manually. So be aware that if you want to put data into the old partitions, you can't just have some data source floating around, so I'm just going to add a partition back in the past. It can't be done that way. You would have to exchange it in, as we'll see in a second. So just be aware of that. You can't add in the past, you can only add to the future. If we look at what our partitions currently are, we've got 3 normal partitions, 17, 18, 19, and 2020, the one we just added, is a external partition, and that's why it's read-only. So if I wanted to swap a data in, I wanted to take, say, an old partition and swap it out with a read-only copy of the data, this is how I do it. As I said, you can't use data pump, you just simply create a data pump format file. So I'm doing create table 2018, it's an external table, it's a data pump format, that's where it's going to go, and I just simply do select star from this partition. So now I've got this partition is relational data. I've now got a copy of that data in a dump file, and I can simply flip it in. So this is very cool. You can simply say, I'm going to archive this data off. I'll create a flat file version of it and simply swap them over. I've now still got the relational copy if I want to do something with it, but generally I'll throw that away. And now I've got this external version, this hybrid partition swapped in for 2018. So if I look at my partition definition, you can see 2020 was the one we added. 2017 and 19 are still normal tables or normal partitions, and 2018 is now a read-only external partition. I can query this just like I can query anything I normally could. So it's just going to work very, very cool. Let's move on to gotcha number 2. Number 2 is, let's flip it back around the other way. So I've taken, as we saw, I took 2018 relational data, swapped it out and replaced it with a flat file. I go, oh, I need to make some alterations to that data now, and obviously it's read-only, so I'll swap it back in, make the changes, and maybe swap it back out. So I swap it back in. This is the second gotcha. When you swap a relational segment back in and swap out a hybrid partition table, be aware it stays read-only. And it's just the way the dictionary works. You actually have to explicitly convert it back to read-write. So this is just a workflow thing. Be aware that if you swap in a relational segment back in place of a hybrid segment, then what happens is it still remains read-only. Just be sure to set to read-write should you need to do it. So just be aware of that. One of the cool things you can do is, even though your table is now half flat files, half relational, you can actually put indexes on it. And as long as they are partial indexes, I've spoken about this in some of my talks before. A partial index obeys what we call the metadata on the partition level, saying whether indexing is on or off. You can do it even with a fully relational partition table. You simply say, I want indexes on that partition, but not that one and that one, etc. With a hybrid partition table, obviously implicitly, if they are hybrid partitions, the flat files, then you won't get indexing on them, and they're indexing partitions. So I'll put some indexes on. It can be a global index, it can be a local index, it doesn't matter. Here's gotcha number 3. If I've got some indexing on there, as we all know, pretty much whenever we're doing exchanges nowadays with tables, we generally want to keep those indexes in sync so we don't have to rebuild them at the end. So you do alter table exchange with updating indexes. And if you run that, you get this. It's currently an unimplemented feature. So at the moment, you cannot do a hybrid to non-hybrid exchange, or vice versa, that have partial indexes and keep the indexes updated at the same time. It's just one of those unfortunate restrictions that we're looking at covering, but at the moment, you can't do it. So what would you do? You would have to do the standard exchange, and like all partitioning things, if you didn't do update indexes, then those indexes become unusable. The global index becomes globally unusable, and the local index becomes unusable on these areas where they were hybrid partitions. So it's not smart enough to know that, well, by definition, that can't be, effectively a valid index. So you need to basically rebuild them. Let me drop the table and recreate the table a bit more realistically now. This is the last gotcha for this one. And this is, tables typically have things like primary keys. In this case, I'm lazy. I'm not going to have a sequence and write my own inserts and use a trigger, anything like that. I'm just going to generate it as identity, which means the database will create a sequence for me and maintain it all for me. So simple table. Once again, the 3 partitions, all relational. I'll insert my massive volumes of data again and go through the same process. Let's tell the database what the external partitions will be, and then I'm going to try swap out effectively my 2018 years worth of data with a dump file as well. So I've created my dump file out there. Here's gotcha number 4. I try swap out that relational table so it becomes a hybrid partition, and it won't let me. Now, why won't it? Well, as you know, when you do an exchange, the 2 objects, the one that's a definition in the partition table and the actual standalone table, need to be identical in structure so we can swap them over. Well, the partition table has a generated as identity clause on it. So that needs to be on your hybrid partition table as well. But you can't have an identity column on a flat file. Makes no sense. So you can't do this, right? Once you have various objects that you could call, or various structures that are relational only, generated as identity, defaults, etc., then you can no longer do the exchange. That's just an unfortunate restriction. So they're the 4 gotchas I wanted to mention. Back to the slides. Is that what I had? Yeah, they're the 4 gotchas I wanted to mention. The basic rule here is, as always, whenever you're exploring a particular piece of functionality that the database offers and you want to exploit it to your advantage, test it thoroughly, try to come up with all the niche cases that your business will require. If you can tick all them off, then you're good to go. If not, you might have to explore workarounds and see what you can come up with. So just a worthy of note. Okay, how are we going for time? Not too bad. Very demo focused tonight, which is good. Okay. Avoiding duplicates. Here's the question that came in. I want to avoid my application adding duplicates, adding duplicate data. Is it better to do a check before the insert or convert? I think that's a typo, convert. Okay, so is it better to do a check before the insert or convert the insert to insert select and add a not exist clause? And my response is neither and both. And let's explore that. We've got a couple of things to explore here. Various ways you can look at in terms of avoiding or making sure you don't get duplicate data. So we're going to start with one, obviously, very important caveat first. Let's create a table called T, insert 100,000 rows, but they're even. You can see it's row number times 2. So effectively, I got 2, 4, 6, 8, 10, etc., etc., etc. So just all the even numbers. If I'm going to test to see if I'm going to insert a row, I'm going to try insert 1001. So here's option 1. Let's see if it's there first. If it's not, then go insert it. And this is my first word of warning, because sadly we still see a lot of this around. Here's the second session using the same logic. I'm going to see if 1001 is there. It's not, which means I can insert it. And as you can see, that's a problem because I've got one row inserted here, one row inserted here. I've got a duplicate, even though I tried to check that there weren't. So rule number 1, that's going to exit out, I think. Yep. Rule number 1 is if you are worrying about duplicates, you must have a unique key or a primary key, depending on the column definition, to ensure that that's not going to be the case. The concept of just checking and then inserting in any way, shape, or form only holds true if you have the underlying database constraints to back it up. If you haven't, you're heading into data corruption street no matter what you do. So that's the sort of standard warning I always give. With that in mind, let's now proceed. So I'll roll back that change. Let's put a primary key on. So we know that the database is enforcing uniqueness now. So with that in place, what's the best way to load data in and not have duplicates go in there, but keep it nice and performant? So here's our first test. Our first test is do the two operations. If I'm going to insert 200,000 rows, first see if it's there. And if it's not there, then do an insert. And it takes 4.5 seconds. So the question is, can we do better? And it's funny how I'm of the school of thought, and a lot of people are, that you really shouldn't do this kind of stuff anyway, because even if you do this check, by the time you finish that check, someone else may have inserted it anyway. And so this isn't guaranteed not to give you an error. This is a false confidence. And so this is indeed the case. So a lot of us, we get taught, don't ever do this. What you really should do is just, I'll recreate the demo, exact same thing. We should do it this way. Try to an insert, and if you get a dupe val index, then null. In this case, I'm ignoring it. You could raise an error, etc. But always do that, because you have to, even if you do a count beforehand, you must always be worried about getting these duplicates anyway. And this is valid advice. But notice how long it took. So the original one took, what was it, 4 seconds, 5 seconds? This one took 20 seconds. If you are expecting lots and lots of duplicates, this concept here is very expensive. If you actually throw a trace on this, which we won't do tonight, what happens is it's an error. You did an insert, you got an error. In your trace file, you have a thing that says a break and a reset. The database goes, oh, something went wrong. Let's sort of get ourselves all sorted out and proceed onwards. Let's roll back that transaction and go, or roll back that statement and go. So handling an error is pretty expensive. So be aware that if you are expecting duplicates, then this is going to cost you. If you're expecting none, then things will be better. If you're planning on duplicates, then yeah, just simply going, well, I'll just catch it and ignore it, is going to cost you a lot in terms of performance. So let's recreate the demo once again, same rows, same primary key, etc., and look at another option. This is converting an insert into select where not exists. Now, don't get me wrong, I've been lazy here in the code. You still need to handle the dupe val on index if this was a real multi-user system. But in simplest form here, you can see we're now getting a significant performance boost. This is faster than doing the select count and then the check, and it's way faster than just handling dupes with an error. So now we're down to 3.8 seconds. So even though you're thinking, well, this seems redundant given that I've got the constraint in place anyway, that check is generally faster than just relying on the error handler. So be aware of that. You're effectively avoiding that database doing a break and a reset as many times as you can. You might still get it occasionally if you're a multi-user system, but this way you're minimizing the occurrences of that. And so it's quite fast. Let's recreate the demo and look at another option. You could do this. One of the cool things we've had for a long time is the merge command can be broken up into fragments. You don't have to do an update. So in this case, I'm doing merge using select from dual. If it's not matched, then do an insert. And I just simply bypass the match thing. Once again, it's about the same speed as doing the count first and then insert. It's not as fast as the insert not exists, but if you've got code generators that like generating merge, then merge is also a candidate that's going to actually run reasonably well. Recreate the demo again, looks at another option. There's a hint that was actually originally designed for addition-based redefinition, but it can be used anywhere. The cost is you need to know the table and you need to know the name of the actual unique constraint that you're looking to avoid violation. But this one gets you very close to the same speed as the insert where not exists. It simply is doing an insert and simply trying to stuff rows in there. So, very, very cool. So that's one you can do. I'm generally not a fan of hints, but maybe this is an exception in the sense that, it's fairly self-explanatory. The risk here is, what if someone renames your constraint? Then that's just going to absolutely blow up. There's no error handling there. So you might have something like, I'll put this in here and as well have the dupe val on index. But then you get the interesting thing of, rather than just catering for boundary cases there where you've got maybe just a few, in this case you could get tens of thousands and get back into that performance nightmare we saw before with dupe val on index. So just something to be aware of. That's why this one's maybe a little bit more risky. Let's recreate the demo and do another example. This is the same example, but this time I'm getting no errors. So I've deliberately chosen the numbers where this will never happen. And we're pretty much close to just standard insert speed. So this is a sort of a final example to show that if you think duplicates are extremely rare, and one would imagine most use case scenarios, you're hoping that data coming in is not going to be existing. If the expectation is duplicates being very rare, then this is going to be fine. Just your standard insert, catch the duplicate. But if there's going to be a high overlap between your incoming data and the existing data, then put an existence check in as well. Even though you have to have the exception handler, do that check first. It's going to be much, much faster. Hence, neither and both. Insert where not exists if you're going to have a lot of duplicates, or maybe use the hint, but just be careful of the risk factor there. If you're not expecting any duplicates, then the unindex exception should be fine. And if you're definitely not expecting duplicates, that's a fatal error, then remove that exception. Right? You want things to crash. If your definition says I should never get a duplicate, otherwise some sort of bug has occurred, then don't cater for it. Let the application crash, because what's the saying? There's a great book called The Pragmatic Programmer, and they say a dead program does a lot less damage than a crippled one. So crash early, crash often. As if you're expecting duplicates, then check. Now, one sort of bias there is at the very first demo, I said we just did select count star, and if it's not there, then do an insert and catch the error, which will be minimal, the minimal occurrences. That's fine because I'm using Pure SQL here. If you're using this in, say, an application tier like Java, C#, Node, etc., be aware that those two statements becomes very costly because they're now coming across the network. And in those cases, select count star, go back to the app tier, do an insert, go back to the app tier. That's going to really hurt you. So be aware that this is perhaps a biased example because we're using all Pure SQL. If you've got applications that are generally using two statements to do this check, look at moving those things into Pure SQL modules and call the Pure SQL module. You'll absolutely knock your latency problems on the head. So worthy of note. 9:52, we might have just enough time for the worst code. It's good that we finish on this. Finish on an uplifting note. Okay. This is a question that came in on DM on Twitter recently. I don't know what the background was, why they were interested. I didn't probe why. I just thought it was a hilarious question. What is the worst code you've seen on a database? And this is one of those times this is back in the days before Oracle, I got called into a customer site as a consultant. Database was having all sorts of server problems. I got called in and they said, can you please help us out? Our server is absolutely on its knees. We're pretty sure our code's fine. Can you have a look? And one of the things I do whenever I used to get called in on a consulting job where the fundamental problem was CPU being bogged down was I had a real simple query, which was this. The most common cause of CPU, the thing that burns CPU on a database more than anything else, is logical I/O. Basically accessing data that's already in memory. There's nothing to stop the CPU, nothing holds it back, there's no I/O. So the CPU just goes, yep, I'll do that, and just absolutely lets rip. So this used to be one of the first things I would run. Let's go look in VDOL or SQL stats where the buffer gets is more than 1 million. Or you just pick a number that you think is going to be useful. Quick footnote, if you have queries against VDOL or SQL, look at using VDOL or SQL stats instead, because VDOL or SQL is your library cache. And so when you query that, you're taking latches and hurting concurrency. VDOL or SQL stats is a separate structure, and you can query that much more aggressively without harming things. But I ran this query, my stock standard query, literally was stored in the script, run the script, and this is what came out. And if you're unfamiliar with SQL Plus or such command line tools, when you get hashes, it means the number you have got back is too big for the formatting size you have allowed. Now, that's an alarm bell because I suddenly realized that my standard script that I'd used at dozens of customers all over the place couldn't fit the number of IOs they were doing. So I had to pad out the number, and it came out something like this. Like literally, I can't remember, 16 billion buffer gets. And look at the queries. Select substring from Joule. Select in-string from Joule. Why? So let's explore. And this is what I call as bad it gets, the worst code I've seen. This was the program. Literally a Peel SQL program. It runs like this. Rather than walk through the code, let's give you a diagrammatic view of what it actually does. If you call that routine with the value 178, what it does is it has this character string list in here with all the ASCII characters except 1 through 9. What it would do is it would say, go get 178. And the first thing it would do is select substring one from dual of the character list. So go get A. And then with A and 178, it would do, is there an A inside 178? So we're an substring and then in string to see if there was an A in 178. Then we would do substring 2 to get the B. Is there a B in 178? And so on. Go get the C. Is there a C in 178? That's what it was doing. And if we ran this just standalone, this is what it was doing. If you passed in 1, 2, 3, the return value was 0. And if you passed in 1, 2, C3, the return value was 1. And after a little bit of banging around, we worked out that this was a checkIf number function. The world's most expensive checkIf number function. And where were they using this? Well, in the system that they had, what happens is every time an external system passed in data, for every row, for every column that was passed in that should have been numeric, they would call this routine. Hence the billions upon billions of calls to select from dual, substring, select in-string from dual. In fact, we worked out that every execution, because this was back in the days of single byte character sets before UTF-8, you had 255 ASCII characters, 244 of them are not numbers. So we do, for every execution to see if some field was numeric, we do 244 select in-strings from dual, 244 select substrings from dual. And back in the version 8 days, that was 5 logical IOs to a query from dual. So you get 2,444 buffer gets every time you call this function called string check. This is the net result. Their server was absolutely on fire, and that's why they called me in. And the cool thing is we have an isNumber function. You know, it's now, and in modern versions, we have some very cool ones. This is what, you know, back in the day when I first dealt with this, but we didn't have these facilities, but in 12C onwards, we could have simply replaced their string check with this validate conversion. It returns 1 or 0, basically if something's a number. If they needed it back as a function, we could use clean number, which simply says rather than just return 1 or 0, we could say try convert it to a number, and if it's not valid, return 1 on a conversion error. So you have a choice. You can either simply get a status, whether it's numeric or not, or this one you could even return the number and return -1 if it was not valid, or any number you choose to return. And of course, if it's a cast function like that and it returns a function, you don't even have to have it in Peel SQL. You could actually code that into your SQL statements. No queries to dual, no in-strings, no substrings, etc. So I said, why did you build this? And they simply said, we're a vendor, we're a database agnostic organization. We write code for all databases. We didn't know about the toNumber function in these facilities. So this is the important thing. This is the importance of load testing. Because what happens is if you run string check for a single field, it runs great. Right? It runs instantaneous because Peel SQL is pretty fast. Even 500 queries to dual is incredibly quick, but 100 executions still fine. But obviously, infinity times infinity is generally times anything is going to end up with infinity. So that's one of my mantras I keep: infinity times anything equals infinity. So it's one of those things. Just be aware. This is the worst example of code I've ever seen. And I won't mention anyone by name. It's no one that I've worked with recently. It was a vendor application. We won't mention the vendor. It's not the blame game, but just one of those things where it's so easy to head down the wrong path. And as long as functionality is correct, it's so easy to forget about the damage it could be doing. Personal story for me was one of the great things was this is one of those things where I came and literally made a 5-line code change to their system. And their system went from 99% CPU to about 25% CPU, like in the space of like an hour. and they thought I was some magician. And yeah, and who was I to set them straight? I told them it was a very complicated, very sophisticated solution that I'd come up with. Anyway, on that note, let me finish off the chat first. Amazingly bad. Oh yeah, everything can be bad. And the last question here. Wilson said, is it possible to control what duplicated row remains and what to ignore? Yes, probably. You'd have to probably do it with a merge to make some decisions there, because merge also, you'd have to merge, you could choose an update or an insert. And if there was a duplicate with an update, you could then say, you can use a where clause inside a merge to decide whether you would update the duplicate value to have some new value, etc. So with a merge, you could probably do it. And on that note, only 40 seconds over. That's surely you'll forgive me that. We are done. Once again, it's great to be back in 2024 for office hours. I'll still keep cranking out videos and blog posts as well. I gave up on the one video a day. I just got too much on in January and February, including heading off to India for a week. But I'll still keep, pushing out the videos. Thank you always for your time. Always love having you on the call. Thank you for those that choose to interact over the chat and the like. Always makes my day to know that we're actually building stronger and stronger bonds. Hopefully we'll see you next month at office hours. I don't know what date it'll be. Or I hope I won't be in India, but we'll see how we go. But there's lots of other office hours. Hopefully you're enjoying the new platform as well. And as I final off, get out there and have a play with VS Code SQL Developer. It's a real game changer. So thank you for your time, and we'll see you next month on Office Hours, everybody. Bye for now.